Now, next, let's move on to our geomatics industry. Geomatics industry is actually a really large industrial sector. It can include land survey, volumetrics, aggregates. It can include general inspection as well as architecture. This is actually one of the industries that really intrigued me when we got introduced to different drone applications. So the first one we actually got introduced to is the volumetric calculation for the construction industry. So imagine back in 2006, a drone manufacturer came to us and said, look, we have a drone, and when it flies over, so take buffering aggregates, for example, the drone can fly over their aggregate site. In 2 hours, you can have calculation of each stockpile that's on site. So you know exactly how much material you have on hand. Next day, you do another round, and now you know the changes. You know how much material has been dug out, how much material has actually been distributed to different client sites. I really thought that was a great feature and a great application, a really niche application for the general construction industry, because traditionally, they have to use whether laser or someone has to climb the stockpile to do the calculation, which can be both time consuming and actually very dangerous. So it was really interesting to see the adoption for that technology. Within a year, we had more than 20 of the large aggregate construction sites sign up through basically the equipment manufacturer. And back in that time, it was SFOC application, was ground school plus additional training. So we're really seeing the industry picking up with that specific niche technology. And then in a couple of years' time, we're basically seeing that technology spread across the general geomatics industry. Because overall, at the end of the day, what does drone survey actually do? So drone survey, in other words, is just capturing the geomatics data from the ground, overlaying that on the images the drone is capturing so that you can have all the data to be processed through different construction or survey type of software. So in other words, we can collect all the information from the ground. Right. So volumetric is just one application of that. It's just using the topography data. So it knows the actual shape of the stockpile, the height change, and the surface square footage. It's using that information to basically do the calculation. Now, applying that to different industry sectors, take land survey, for example. This can basically give us topography topo information. So what do we do with topo information? For example, before a land is being built during development, we would come in with a drone and we would capture the topo data and send that data to the engineering firm. The engineering firm would base their evaluation on the topo data. In other words, how much of elevation difference, how much of a change is on that land, how much material and how much work is required. So that's what the engineering firm will use to do the calculation. Now, during construction, the drone would also come back whether to capture the actual when raw material is being delivered. The drone is coming back to do the stockpile calculation. During different stages of the construction progress, the drone can come in to do the construction progress monitoring. For example, the drone 360 application I just showed for film and media, we're actually seeing that being used more in construction project monitoring, project progress monitoring. For example, last year we were using drone deploy to capture the 360. So what you can do is when we went on fully undeveloped sites to do survey, it was challenging to do flight planning. Because if you look at Google Earth, if you look at a development site on Google Earth, typically that map is outdated, right? It's probably showing trees, it's showing things from years ago. So if I want to have an updated information about the location so I can do my proper flight planning, I can actually do a quick survey with drone deploy, and it's just stitching all the images together for me, similar to the 360 application. So within 30 minutes of being on site, I can actually have an updated map, a real-time map of this location overlaid on Google Maps on my flight mission planning app, so that I can determine where am I flying, how am I flying, or where can I actually drive to, where can I actually access to conduct my mission on site. So it's actually super useful. In other words, for the general geomatics industry, what we're seeing is really more of the integration. It's collecting the image and the mapping data, and it's having the integration with the workflow. One is making sure that drone equipment is compatible with the survey equipment. For example, we use the RTK model when we actually fly for precision survey. If you look at a typical drone, whether it's a Mavic 2 Pro or a Phantom 4, even for the larger matrix units, if you look at any typical prosumer type of drone, the GPS accuracy on them is anywhere between 2 to 5 meters. And for precision survey, we need to get the topo data accuracy down to 2 to 10 centimeters. So really, that's a huge difference. We're talking about almost 100 times of difference. So how do we achieve that? First of all, you need to have a software algorithm. So when the images are being stitched together, there's overlay to correct the GPS accuracy. Two is introducing whether the RTK, which is your real-time kinetics, or your ground control points, which allows you to correct the GPS data after you capture the map information. For example, with ground control points, the simple way to put it is the drone does its survey and collects the GPS coordinates, but on the ground, I'm also collecting using the high-end GPS modules for survey purpose. I can actually collect the accurate GPS data for specific points on site. And then when processing the map, I can introduce those points into the map and calibrate it for the whole drone survey map. So that's with the traditional ground control points. And with RTK, you're basically introducing a separate RTK station. There's also another one called RTN, real-time network, that allows you to connect to a network that's provided by any geomatics information or a geomatics provider. So sometimes they can also be called benchmarks. That allows you to connect to known points and also correct the GPS data collected from the drone. In other words, it's the drone having the ability to work with different types of survey equipment in order to save time and also provide better accuracy. Because if you look at a traditionally land development, let's say 20 acres of land development, it's actually very challenging for a land surveyor. Typically, when they do topo survey, one is they can stand there to look at the land and take the guess. Two is they can take their GPS station and manually walk to different spots of the land to collect the data to draw the topography chart. Where do they go to collect those data? It's purely based on the person's judgment and based on the site condition, the seasonal condition of where they can actually go. So in other words, there's a lot of personal judgment involved on whether or not the equipment is capable, the person is capable of making those judgment calls. But with a drone survey, the drone is scanning the entire site and collecting the data and basically composing them into post-processing to give you the topography data. So that's the difference. There's always pros and cons for both applications, but with drones or with any technologies today, it's a matter of trying to eliminate the personal judgment and the personal error, trying to standardize the entire operation. So one site, from site to site, if it's the same drone scanning through the site, you're basically working with the same potential error rate or potential issue. Versus if you have different people surveying different land, it's all based on their own personal judgment, which is going to be different from site to site.